How does mass relate to gravity? Imagine holding a ball in your hand and dropping it. It falls to the ground because of a force pulling it down. That force is gravity, and it depends on the mass of objects involved. Gravity is a force that pulls objects toward each other, and the stronger the pull, the more massive the objects are. The more mass an object has, the more gravity it produces. For example, Earth's large mass creates a strong pull that keeps everything on its surface, including us. If Earth's mass doubled, the gravity pulling on objects would also double, assuming the distance stays the same. That's because gravity depends directly on mass. This idea was first put into clear words by Sir Isaac Newton in the late 1600s. He created a formula called the law of universal gravitation. It explains how every object with mass attracts every other object with mass. The formula says that the force of gravity equals a constant times the product of the two masses divided by the square of the distance between them. This means that if the masses increase, the force gets stronger. If the distance between the objects gets bigger, the force gets weaker. Newton's formula was a huge step forward because it explained not just why apples fall from trees but also how planets orbit the sun. In 1798, scientists built on Newton's work with the Cavendish experiment. They measured the gravitational constant, which is part of Newton's formula. This experiment used a very sensitive setup with large lead balls and a torsion balance. It allowed scientists to find the exact strength of gravity between known masses. This was a major milestone because it turned a mathematical idea into a measurable, real-world fact. On Earth, your weight is a direct result of gravity acting on your mass. Your mass stays the same no matter where you are, but your weight changes if gravity changes. For example, on the Moon, gravity is weaker, so you weigh less but your mass remains the same. In space, astronauts float because they are in free fall, but their mass stays constant. Looking at the universe, the mass of planets, stars, and galaxies shapes their gravitational fields. Jupiter's huge mass pulls on nearby moons and asteroids, affecting their paths. The more mass a celestial body has, the stronger its gravitational influence. This is why massive objects like black holes have such powerful pulls that even light cannot escape. In short, mass is the key factor in gravity because it determines how strong the gravitational pull between objects will be. Newton's formulation and the Cavendish experiment helped us understand this relationship clearly. This understanding has helped us explore everything from the motion of planets to the behavior of objects in space.